Welcome to the PSCAD video tutorial. In this tutorial, we will be covering the following: an overview of the root control interface example, and how to set up and batch run dependent simulations. The root control project is an example of how to perform large-scale optimization with parallel processing. It does this by allowing parallel simulations to send their results to a master project. The master can then use the results to calculate optimum tuning parameters for the next iteration of runs. These new parameters are then fed back into the slaves. The slaves are simulated again, forming a closed-loop simulation. Multiple CPU cores are utilized to quickly simulate many scenarios. This process continues until optimum tuning is achieved. The root control example is made up of a master project called Chopper Optimization and 3 slave projects called Choppers 1 to 3. The chopper projects are essentially a circuit to be tuned with different initial values and a PI controller. These slaves are identical in design, but they differ in settings. You can see here that the power level is different in every case. The master project uses the objective values from each slave and then recalculates new initial parameters for each slave. This is essentially done with the PSCAD Optimum Run component. Now let's see how we set this up. You can set the master-slave relationship in the project settings. PSCAD will then know which project is managing and which ones are doing the work. Let's look at the master project first. The data being passed between the master and slaves is done via the radio links. These particular radio links are receiving data from the slaves. In this example, they are the objective values. Note parameters for the radio links. Each one is set to receive data from a different slave. The objective values are plotted here. And used here with PSCAD Optimum Run component. New tuning parameters are then calculated for the chopper slaves. Once they are calculated, they are then transmitted through the radio links. Now let's have a look at one of the chopper slaves. The initial values from the master come in through the receivers. Note that the receiver is explicitly set to receive data from the main page of the master project. Now let's take a look at the signals that were brought in. You can see that we are initializing the inductor and capacitor values of the chopper circuit. The other 2 signals are setting the proportional gain and integral time constant of the PI controller. Once this slave project is done running, the new objective values are transmitted by each slave. If you now go back to the master project, we will have come back to where things began. Let's run it and see what happens. Here in the master project, you can see the objective values coming from each slave. In each chopper slave, you can see the output of the circuit for that power level. The output changes for each run as new tuning parameters come from the master. Back in the master project, the objective values from the slaves approach a tolerance level of 0.01. The optimum run component is configured to drive the slave simulations until it has reached either the maximum number of runs or the tolerance. You can see those values set here. In this example, we can see that the tolerance was reached at run 74. At that time, the master project, driven by the optimum run component, stopped all simulations. The optimum tuning parameters for the chopper circuit and the controls have been found. You can see the best parameters to tune the circuit here. And you can see the best parameters for tuning the PI controller here. In conclusion, this was an example of how simulation sets and project signal sharing can be used for large-scale optimization with parallel processing. We hope that you have enjoyed this tutorial. If there are any videos that you would like to see made in the future, please let us know. Thank you and enjoy PSCAD.